To create a system architecture model, you need a few things. These are a modeling language in an appropriate tool and a modeling method. When they are applied right, the system architecture model is created, but that is not the end of the story. Besides the necessary infrastructure and the organization, it is you. You have to understand the importance of a system architecture model, know how it can be created, and of course you have to use this model in the development process. You have to integrate it, communicate it, and collaborate with it, of course. If that is not done, it's pretty much worthless. We can only show you the methods, the languages, and the tools in this course. The other part is your job in your specific organization. As we already know, creating a system architecture model in the context of MBSE in the system design phases, the triangle of modeling languages, methods, and tools is necessary. Removing one of them is fatal and definitely leads to an improper model. Engineers who begin with the topic of MBSE and system modeling often don't use appropriate modeling methods. And at first it looks like if it was possible that the system architecture model is created without a specific modeling language. But then often important relations between artifacts are not modeled. The model structure is chaotic, that's what we see a lot, and essential information is maybe classified wrong. Only with all three parts, so languages, the methods, and the tools, an appropriate system model can be created, that's for sure. And of course, the most contribution is provided by the right engineer, so by you. There are different modeling languages available, whereby the most popular is SysML, followed by the Capella language. You may know one or both of them. Not for every type of problem, project, and organization, every modeling language fits well. Select the right modeling language carefully. Take your time for that. Also, maybe the semi-formalized modeling language is an overkill for the planned usage. That's often the case as well. Maybe a semi-formalized modeling language is a must. That's also possible. Both have advantages and disadvantages and should be considered with care. Semi-formalized modeling languages have benefits in better interpretation of the model content and, of course, the processability by the computer, but require time to learn and even more time to create the model itself. Informal modeling languages behave in the opposite way. They are fast and straightforward, but are not understandable by the computer. Besides different modeling languages, there are different modeling methods available in the context of MBSE. These methods describe the way from a problem, which is modeled, to the solution, that is then also modeled. The steps to get to the solution follow a modeling method, which has a target to guide and to connect all the different steps and, of course, their content. Similar to the modeling languages, not every modeling method fits well to every kind of problem, type of project, and the development philosophy in the organization, maybe. The right modeling method must be selected as well, very carefully. And finally, we have the modeling tools to create the architecture model. As SysML is the most popular modeling language, there exist several modeling tools that have implemented SysML. Each of them has some differences, but overall the way of working with and in the tools is pretty much similar. Most SysML modeling tools require a paid license, but there is also Eclipse Papyrus, the full open source solution, and Modelio, the partly open source solution. Besides the SysML modeling tools, other tools for other modeling languages are available, such as the Capella modeling tool, which is also open source. Besides the modeling language market leader SysML, the Capella language has strong growth. Reasons for that are the open source approach, of course, the modeling method that is integrated into the modeling tool and tailored to the modeling language, and many more. Let's bring all the just heard together a little bit by the example of Capella. The Capella modeling tool contains the transmission architecture model, for example, created by the Capella modeling language. The creation of the model is guided and supported by the application of the Arcadia method. So the creation of the model by using the Arcadia method requires inputs, such as requirements or stakeholders, and creates as an output the system architecture model. But there is one thing missing, and that is you. Someone who knows different modeling languages, methods, and tools, understands their mechanism, and knows how to bring the system modeling activities into the development process so that other activities and team member can benefit.